Alright, so for number 9, we've got C here, 3 cosine squared minus 2 cosine x minus 1. This even looks like a quadratic trinomial. I can even rewrite it like a quadratic trinomial. And if I want, I can pretend like I'm factoring it like a quadratic trinomial. Let's see, negative 3, 1. Alright, so that would mean these are the opposite of my answers. Now keep in mind, this is not what x equals, it's what cosine x equals. Cosine x is going to equal 1, and cosine x is going to equal negative 1/3. That's one way to go about it. Some of you aren't fond of factoring, I get that. You could use the quadratic formula. We've got a of 3 and b of negative 2, and we've got c of negative 1. You could write it down, and you could write this out. Now, my suggestion is, once you've written it down and established your method, is you go to the calculator and plug in a, b, and c, and find out that the answers are 1 and negative 1/3. And again, remember, this is not what x equals, this is what cosine x equals, but then you can carry on and see the hard part's been done. All I've got to do now is take the inverse of cosine at 1 and inverse of cosine negative 1/3. Well, let's see, let's get back to computations. Okay, so let's see here. Put a 1 in there, that's going to be a 0. So remember, if it's on the x-axis, it's not going to reflect anywhere, but that doesn't mean I can't add 360 to it if I don't want to, and if I add 360, it's still going to be within the range, or the domain, I guess I should say, of 360 degrees, so that's 2 answers there, 0 and 360. And then when I put a negative 1/3 in here, I'm going to get the number 109.5. And that's degrees. And so now if I give a quick sketch of that, be careful, it's over here in the second quadrant, so that means that's going to be down here. And so essentially the other angle is going to be 360 minus 109.5. And so if I just take my calculator and do that real quick, I'm going to find out that the other answer is 250.2, or 5 I mean. And I'm good to go. There's no more answers within the domain. Now this one kind of looks like a quadratic trinomial, but you'll notice it's got cosine and sine. One of the things to keep in mind is the identity of sine squared plus cosine squared is equal to 1. Now you may be tempted to divide everything by cosine, but that doesn't really work in this case, because if I do 1 divided by cosine, it kind of falls apart. So in this case, I'm going to replace the sine squared with 1 minus cosine squared. And see, then I'm going to have all cosines, and all I got to do now is distribute this 2 and combine like terms, and I'm going to get a quadratic trinomial. And I could do stuff like try to get it not to be negative, but I'm just going to go ahead and use the quadratic formula for this. I'm going to, a is negative 2, b is negative 1, and c. And again, to establish a method, I'm just going to write out like I'm going to do the quadratic formula, and then I'm going to go to my calculator, and I'm going to find out what the answers are. And so let's see, menu A, number 2, second degree. A is negative 2, B is negative 1, C is 1. Find out one of my answers is 1/2. Now keep in mind, that's cosine x is equal to 1/2, and cosine x is equal to negative 1. So I write that down. And then I just got to finish up by taking the inverse of cosine, putting a 1/2 in there. Taking the inverse of cosine, put a negative 1 in there. I find out if I get my calculator, let's see, get back to computations here. Inverse cosine of 1/2 or 0.5 is going to be 60 degrees. And if I go across the x-axis, the other angle that's positive is going to be 300. And then I go and put a negative 1 inside here for the inverse of cosine, and I get 180 degrees. And again, that's on the x-axis. And if I add or subtract 360, it's going to be outside the domain. So this is the only answer I get for this one. And so I've got 3 angles that answer this equation. And I'm all set. I'm good to go. All right. Thanks for watching. I hope that helped.